Okay, so what's our last class? What is our last class?
We did the 2 sample t-test.
T-test and something else, right? Sample, one sample T-test and two sample
2 sample t-test.
and paired sample T-test.
Yes.
How many sample? How many T-tests I done? And even
Um,
this Welk T-test also we done, right? Total we have the four sample T-tests we done, right? So one more time, I would like to tell you the count of those things. So we have a T-tests. Okay. Okay. We have a T-test, right? So in a T-test, so we did it. One sample T-tests, one sample T-test, T-test, two sample T-test. Okay. Next one is paired sample T-test, right? And what about next one? Walks T-test, right? Yes or no? Only these things we did it or any other? One sample T-test and Wilks T-test, paired sample T-test, right? The only four we did it, right? Yes or no? So these are the four tests we did it. Now, even from the T-test only, we have a two more tests are there. Okay, which is sometimes we are going to be using it. Those are those are those are Mann-Whitney test, Mann Whitney test, Whitney t-test. So here this is the replicable of the two sample and two sample and paired sample test. Basically, two sample test means what? We have the two groups are there. We have the group 1 and group 2. These two groups are independent, right? These two groups are independent. But coming to the paired sample t-test, the group 1 we have it and group 2 we have it. Again, we are going to be comparing the means of these two groups only. But these are paired to each other. One observation which might be paired in another group. Okay, or before and after meditation or some different kind of examples we have it. For example, your IQ level before meditation and after meditation course. Okay, or else your performance in the one particular exam before practice and after practice. Okay, so that kind of things actually. Okay, so here we have a dependentness. We have it. One group of observation, the one observation in one group, it might be depending on the or it might be paired to the another group observation. Okay, is it clear? But coming to the Welk t-test, here the variances are different. Variances are not same. Then we are going to be using the Welk t-test. But when coming to the Mann-Whitney t-test, we have another name for this one is Will Coxzone, okay, rank some test. So we have another name for this particular Mann-Whitney t-test is Wilcoxon rank sum test. See here, the main importance of this thing is, so this two sample t-test, we have another name is student t-test. Student t-test. Okay, which is same as the application of the two sample t-test, or the principle of the two sample t-test, which is replica of the Mann-Whitney actually. Okay, so you can simply say that, and this could be a same as what? Same as two sample t-test. So you might be thinking, then what is the difference between the two sample t-test and Mann-Whitney test? So here it's a very simple thing you need to remember actually. For example, let me go for two sample test only. Let me go for the two sample t-test. Okay, and when we are going to understanding the two sample t-test, here we have the one group, or we have the population 1, we have the population 2. Let me consider this is my entire population. Okay, this is my, I have another population, both are independent, so I have to take it some group from this one. Okay, this is my sample 1. Okay, this is my sample 2 from the population. Okay, so this size, it could be less than the 30 when you are applying the t-test. When we are applying the t-test, the sample size is less than 30. Okay, that means n could be less than the 30. And we have one more thing is no population information. Okay, population standard deviation is unknown. This is the two things we need to remember it actually. When we are applying the t-test, it may be one sample t-test, two sample t-test, paired sample t-test, or else a Mann-Whitney test, or Wilks t-test. Okay, or else we have another Wilcoxon signed rank test actually. So whatever the t-test, here the sample size, it could be less than the 30, and moreover population standard deviation is it's unknown. Okay, that situation we would like to go for apply the t-test. Now let's go for understanding the two sample t-test. So two sample tests, where we should apply actually, when we have two populations are there, but have the sample size is less than the 30 and less than the 30, with help of this particular two samples, I have to compare the mean of the population 1 and mean of the population 2. By this time, whatever the sample we have it, these two samples are the normal distribution. When we plot the samples, you will be getting the graph, something, the distribution graph, it could be something like this. Okay, the distribution graph should be like this. When the two samples are normally distributed, then we would like to go for the two sample t-test. For example, okay, for example, so now we would like to go for understanding the Mann-Whitney, right? Mann-Whitney test. Mann-Whitney test, which is exactly the two populations we have it, same like a two sample t-test. Okay, this is my population 1 and this is my population 2. Okay, these two populations are independent. Yes, it's independent, but I have to compare the mean of this population, I have to compare the mean of population 2. So here I have the sample 1 and here I have the sample 1. Okay, here also I don't know anything about population standard deviation. I don't know anything about population standard deviation, population to standard deviation. But thing is that here this sample and this sample are not normal, not normal. That means when you plot the graph, you won't get the graph. Okay, you won't get any graph something like this. You're not getting this kind of graphs. Okay, so you might be getting the some values. So the distribution graph is not normal. That kind of situation we would like to go for apply the Mann-Whitney test. Clear? So here this if and only if the two samples are the not normally distributed, then you would like to go for the this Mann-Whitney test. We have another name for this Mann-Whitney test is Mann-Whitney test is, what is the name? Wilcoxon rank sum test. Rank sum test. Okay, so what exactly this one? So when we have a two samples, we have to statement of the null hypothesis, we have to statement of the alternate hypothesis. For example, if the statement of the null hypothesis is if the two populations are equal, two populations are equal, or two population means are equal, whatever it is, two populations are equal. Okay, so here you can say that two populations are not equal. Two populations are not equal. This is my alternate hypothesis and null hypothesis. Then how we can able to derive actually? So based upon the rank, so here we have the U1. This is Mann-Whitney U test. It's not t-test, as Mann-Whitney U test. So you can say that you have to derive the U1. U1 is N1 into N2. Here N1 is the sample size 1, N2 is the sample size 2. Okay, and then N1 into N1 plus 1. Okay, minus of R1. R1 is rank 1. Okay, it's a sample 1 rank. For example, we have the N2, so V2 N1 into N2 plus N2 of N2 minus 1. Okay, so minus of R2. When we have these two things, we have to derive the, or we have to find the U value. So the U value is it's a very simple thing, the smallest value of absolute smallest value, OBS of U1 and OBS of U2. Okay, so absolute in the sense even you are getting the positive or negative, you have to do it absolute value. Okay, this situation, whichever the thing is smallest one, that it could be considered as the U value. If you know the U value, then you have to know the degree of freedom. Degree of freedom is N1 plus N2 minus 1, right? If you know the degree of freedom, and you can easily calculate the p-value. If the p-value is again less than the 0.05, we should reject the null hypothesis. If the p-value is more than the 0.05, we should accepting the null hypothesis. You might be thinking how we can able to calculate the R1 and R2, right? It's a ranking, it's just ranks. For example, we have the two samples are there. Okay, you have the two samples are there. So this is my sample 1, this is my sample 2. Okay, sample 1 is 1 and this is 2 and this is 4 and this is 2 and this is 1 or else 6. This is for example 5, for example this is 6. Okay, like this we have it. Now what you should actually, so sample 1 is 1. We have to make it this all things, it could be in order 1 2 1 2 3 4 and 5 and 6, right? So this is all the values. So but this is sample 1 and this is sample 1, this is the value is sample 1 again. Okay, now what I should do actually, okay, the rank is, it's a rank 1, this is rank 2, this is rank 3, this is rank 4, but actually here values are let me consider this is 10 30 40 let me continue because of you might be confused yourself. Okay, so 10, 20, 30, 40 and 50, and let me consider 60. This is rank 1, 2, 3, 4 and 5, and this is a 5. This is the 5 and 6. This time what could be the sum of the rank 1? Rank 1 sum is, rank 1 sum is, so this is the value of the rank 1, this is the value of the sample, these are the ranks of the sample 1. So 1 plus 4 plus 5. Okay, it's a 10. For example, rank 2 is 2 plus 3 plus 6. What it is? 8, 11. 11. Yes, this is the rank values. So you already know that sample 1, sample size 1, sample size 1 and sample size 2, and you know the R1 and R2, then we can calculate the U1 value and U2 value. Then we have to make it absolute value of the U1 and U2. Then from this one you have to find out the U value, right? If you know the U value from the U table, whatever it is, we can easily calculate the no this kind of we can figure out the Mann-Whitney test. Okay, when the population, the samples are not normal. Now we have one more topic, or we have one more test is there. The test name is, it's again Wilcoxon signed rank test. So this situation, there the populations are same, I mean paired, so which is similar to the paired sample t-test. So when one particular group, it may be one group of samples or observations are paired to the another group, right? Paired sample t-test. Okay, so there also the samples are not normal distributed, not normal. This situation only we would like to go for Wilcoxon signed rank test. Okay, these two things we can try with the Python programming language. So you have to go for open the Anaconda Navigator. Launch. Desktop. That's okay. You just observe here. So here we have the group 1 and the group 2. If you want to be performing the Mann-Whitney U test, then we have to import this particular library. Inside of this library, we have the name is Mann-Whitney U. Okay, here we have to provide the group 1 and the group 2, and alternative use, it's always two-sided actually. With the p-value, you just calculated the p-value from this particular Python code. Okay, just this is the function, you should remember it, and we just providing the group 1 value and group 2 values, and these two values are which are not normally distributed. Even we can plot the histogram for this one, even we can plot the histogram for this group 2, you are not getting any kind of okay histogram with the normal distribution. Now performing the Wilcoxon signed rank test, so which is also very similar to this one, but here we have a direct formula Wilcoxon, and here we have to provide the group 1 and group 2. So this is the thing, it's a paired sample and not the samples are not normal distributions. Okay, that situation we can use this particular function. Clear right? You can try to be execute these things in your Python. I just wait for 1 minute. You just try to execute this thing. Guys, today I would like to share you this document in your stats document. Once it is done, please let me know. I'm waiting for your confirmation. Done, right? Yes. Let's go for the jet test. So guys, here you should try to be understood the difference between the jet test and a t test. So for example, a t test and jet test. When we should apply the t test and jet test is, the first primary thing is sample size. Sample size. For example, with the sample size, we can consider the n. Okay, if n is greater than 30, then I would like to go for the Z test. If n value is less than the 30, then I would like to go for the t test. Okay, and one more thing is that you should have the sample size is more than the 30, and one extra qualification we require: population standard deviation. Population standard deviation is what? It's a sigma, right? Population standard deviation means it's a sigma. Okay, sigma, you should know. Known thing, that means known in the sense we should know the population standard deviation. If you know the population standard deviation and the sample size is more than the 30, then I would like to go for the Z test. And the population size is population standard deviation is unknown. If the population standard deviation is unknown, then I would like to look for the t test actually. Clear? I hope you understood, right, when we should apply the t test and when we should apply the Z test. And coming to the Z test, which is working based upon the Z score. So there are four type of Z tests are there. Here also one sample Z test, and second one is the two sample Z test, and third one is the one proportion Z test, and the fourth one is the two proportions Z test. So this kind of situations, this is the four type of Z tests are there. So depends upon the requirement, we would like to go for that corresponding Z test actually. Okay, so coming to this particular one sample t test. So one sample t test means we have only one group. Okay, so this is my population group. So this is the mean value. I have to check with some value. I have to be compared with one particular value. Then I would like to go for the one sample t test. This time, whatever the sample size I have it, that it could be more than the 30. And moreover, I should know the population standard deviation. That time, so you have to use the Z value if you want to calculate the Z value. So you already know the sample data, right? So that we have to calculate the sample mean minus and population mean. Population mean means whatever the value you given here, that value by, and you already know the population standard deviation. So population standard deviation by square root of the sample size. So this is the formula for the to find the Z. Okay, if you know the Z and if you know the degree of freedom, degree of freedom is it's n minus 1. If you know the Z value and the degree of freedom, we can easily calculate the p value. Again, the p value is the more than the 0.05. You should accept the null hypothesis. What is null hypothesis? Null hypothesis is your mean is which is equal to some constant value. Okay, some constant value. Clear. Alternate hypothesis is your mean is it which is not equal to the your constant value. Clear. I can show you the code in one shot. Actually, before that I just need to explain this all Z tests. Now two sample Z test. Two sample Z test in the sense you have the two groups are there. You have the two populations are there. This is my population 1, this is my population 2, and I have the corresponding this is my sample 1, this is my sample 2. Okay, and here my n1 is which is must be greater than the 30, and here also my n2 is it must be greater than 30 value, and I should know the standard deviation of this particular population. I should know the standard deviation of the population 2. Okay, so if you know this thing, we can calculate it the mean of sample 1 and mean of sample 2 I have to be calculated. Okay, if you know these two things, if you know these values, so first of all, when we can apply these two samples, when the two populations are two different groups, both are independent, that situation you would like to go for the two sample Z test. So how we can able to calculate the Z value? So if you want to calculate the Z value, my mean population, my sample mean 1, sample 2 mean by, okay, square root of standard deviation 1 square by n1 plus standard deviation 2 square by n2. This is the formula for the okay. This is the formula for the okay. So two sample Z test. Here also you have to be you know the degree of freedom. My degree of freedom is n1 plus n2 minus 1. This is the degree of freedom. If you know the degree of freedom, if you know the Z value from the Z table, we can calculate the p value, or else we can go for the any corresponding programming language. Okay, if you are using the R language, then we can have the R language related code. If you're using the Python, then we should use the Python code. Okay, that is a one type of question. If you're getting that type of question, we can go for the two sample Z test. But here we have the third one is which is the one portion proportion Z test. So one proportion Z test in the sense, so you are introducing one thing. Okay, you are introducing one thing. You want to go with how many people will go for accepting this one. Okay, what could be the percentage of the people are accepting that one particular, okay, rule. You're passing on particular rule actually. Okay, this rule, you have the, for example, 1 crore of people are there. Okay, you're passing one rule from this particular 1 crore of people. How many people are accepting this rule and how many people are rejecting this rule, right? For that one, if you have the population, from that particular population you should take this some kind of sample data. So this sample data, it must be more than the 30. Okay, so from this particular this is the sample size is your n value, right? Your n value. Okay, so your n value, it must be more than 30. Now from this particular sample of people, maybe some people are accepting this one, right? That is the portion that we can consider the p value. Okay, so p value or p. So this is the proportion, this is the proportion test. We should remember the two values, p naught and p-value. So p-value is your your uh, your population proportion. So here we have the 1,000 people are there, right? So this is your population proportion. Okay, population proportion. Okay, and p naught is it's your observed population proportion actually. Okay, or else hypothesized. Okay, so this situation, if this is the value which is which is the hypothetical value, this is your practical value. Okay, this is your practical. This is the two things you want to compare actually. That means your alternate hypothesis is your population proportion, which is equal to the hypothesized population proportion. Okay, so for this one we can have the formula for the z is z formula. So z score is always changed based upon the problem statement you are using. The z score is your population proportion minus I sorry population proportion minus hypothesized population proportion by, okay, square root of hypothesized population proportion 1 minus hypothesis population proportion by n. This is the thing. Okay, so which this kind of situation your degree of freedom is absolutely n minus 1, right? Now, so even this kind of problems also you can able to solve it when you have one particular thing, proportions. When you are considering the proportions, okay, then that situations we would like to go for this particular proportion thing. Now what we should do, two proportions in the sense two different things, same rule you're passing. This is one population, this is another population. Okay, same rule you passed here, and how many people are accepting this rule and how many people are accepting this rule, that we are calling it the proportion of the population 1, proportion of the population 2. This is the two proportions I want to be compared. That situation we can go ahead the two population two population two proportions z test. Okay, so here for example, my population proportion pi 1, okay, my population proportion pi 2. So I want to compare these two things. This is my population proportion, this is my population proportion 2. Okay, so here I have to calculate the z. My z is population proportion 1 minus the population proportion 2, okay, by square root of the p, square root of p. So 1 minus p 1 by n1 plus n by n2. Okay, so this is the thing, but you should know the what exactly the p value, right? P value is its population. Okay, so which we can calculate the population proportion 1 into sample size 1 plus population proportion 2 into sample size 2, okay, by n1 plus n2, by n1 plus n2. This is the formula. With help of this particular formula we can substitute in this particular z. From this one we can calculate the z value, and from the degree of freedom we can able to calculate the your corresponding p value actually. So this is the way you can able to do this thing. One sample z test, two sample z test, one proportion z test, and two proportions z test. Okay, these are the four things we can do within your Python programming language. So what you should actually, you can just go ahead this particular thing. So in the stats model we have the stats thing, and we have the weights stats. From this particular library we are going to we are able to go for importing your z test. Okay, if your z test is for example, this is my data, So this is my data. So you have to provide the data and your constant value, right? So my population, I would like to compare the population mean. I want to compare with this particular value. Okay. If this is the p-value, this is the p-value is which is greater than the 0.05. That means my population proportion, my population mean, which is equal to the 100. Okay. Now, when it is the two sample test, same thing. Here we have again we are going to be using the jet test only, but here you are going to be performing the two different areas. Okay, both are independent. Okay, this is one group and this is group two. These two groups I want to compare the means of this population city A and population city B. Okay, so if you are getting the p-value is it's a less than the 0.05, which means that city A and city B both are different. Okay, and performing the one proportion jet test in the sense from the stats we have the proportions library is there. From this one we have to import the proportions jet test, and there you should find send the it's a count is nothing but your success rate. Okay, how many people are accepting that particular rule, and total population. Okay, so total sample. Okay, from this particular 100 people, 80 people are accepting the your rule actually. Okay, this is your hypothesis rule, hypothesis proportion rule. So your population, your population proportions which is equal to the 0.64 or not, that you're going to be figuring out. As of course it's a true because of your p-value is it's a less than the greater than 0.05. When we have the two groups, so the two groups of the this is sample success rate and this is sample to success rate. This is my sample size 1, this is my sample size 2. When you have this kind of two things, then what I should actually, I can able to compare the sample size population proportion 1 and population proportion 2. This way we can able to find the p-value. If the p-value is the population, if the p-value is greater than 0.05, we should say that okay, these two population proportions are same. Okay, so this way we can compare the this all things, guys. Okay, anyway, I would like to send you this particular document in our canvas. You can able to go for access this particular file. Okay, see the corresponding file I'm putting in top of it. Okay, so we can go ahead and access this one. Okay, you can download and we can look for this one. Okay, and I can upload the recording here as well, recording about jet test. In this particular file you have the jet test and t test related document is that we can download and we can practice it. I hope you guys are clear about t-test and jet test. Okay, and by tomorrow's session we'll talk about the chi-square test and ANOVA test. Then we can conclude that hypothesis testings concepts. Bye guys, see you.
Thank you.
Yeah, thank you.